welcome back to my channel Gain of Knowledge. So guys, today let's learn about bases and salts. Before that, we learned the acids in detail in our last video, that is the part 1 video. In this part 1 video, I have explained you detailedly about acids. In this video, let's learn about the bases and the salts. Now, what are bases? Bases are substances that react with acid and neutralize them to form salts. They are mainly the oxides or hydroxides of metals. They are generally insoluble in water. However, bases like sodium hydroxide and potassium hydroxide dissolve in the water and release the hydroxyl ion OH minus. Such bases which are soluble in water are known as alkalis. This implies that all alkalis are bases, but all bases need not to be alkalis. Carbonates and hydrogen carbonates, bicarbonates, are also bases. Ammonium hydroxide with the chemical formula NH4OH is a widely used base, although it has no metal atom. Now, now types of bases. Depending on their ionizing ability, bases can be categorized as strong and weak bases. Strong bases ionize completely, whereas weak bases only partially break up into ions. Concentrated strong bases such as sodium hydroxide NaOH, potassium hydroxide KOH, etc. are very corrosive. Care should be taken while handling them as they can burn the skin and cause blisters. Weak bases such as zinc hydroxide, copper hydroxide, etc. are not very corrosive. Now let's head to the properties of bases. They taste bitter, they are slippery to touch, they turn red litmus paper blue. When in solution form, they can conduct electricity. Bases have a strong odor and can harm the eyes and skin. Now let's move to the uses of the bases. Calcium hydroxide. To prepare whitewash used on buildings, fences, etc. In the construction industry, it is used to make lime mortar. To prepare lime water, which is used to test for the presence of carbon dioxide. To neutralize the acidity of soil. When chemical fertilizers are used in excess, the soil becomes acidic and plants are unable to grow in it. Adding calcium hydroxide to the soil neutralizes the acid effects and makes it suitable for plants. Next is sodium hydroxide. It's also known as caustic soda. In the manufacture of paper and textiles, an important ingredient of soaps as well as detergents. As a household drain cleaner, as glass cleaners to clean windows, mirrors, and other household articles. As a stain remover in the manufacture of nylons, plastics, etc. Next is magnesium hydroxide. It's also known as the milk of magnesia. It is an antacid. It helps to neutralize acidity caused because of the excessive secretion of hydrochloric acid in the stomach that leads to indigestion. Now let's move to the another topic, that is the indicators. Most substances simply cannot be tested as they may be corrosive and dangerous. How would you find out the nature of such a substance? Is it an acid, base, or a neutral substance? A safer way to use certain chemicals called indicator to find out the nature of substance. They indicate whether a substance is acidic or basic. Indicators are usually weak organic acids or bases that change color in an acidic or alkaline medium. There are two types of indicators: natural indicators and synthetic indicators. Natural indicators are prepared from organic matter like animals, plants, or their parts. Almost any petal, leaf, or root of a plant that is brightly colored red, blue, purple, etc., can be used to prepare a natural indicator. For example, litmus. Litmus is an extract of lichens, that is a living organisms, and turmeric, show flower petals, red or purple cabbage, etc., are natural indicators. Synthetic or artificial indicators are made from chemicals and are usually prepared in laboratories. Phenolphthalein, methyl orange, and methyl red are examples of synthetic indicators. Now, let's move to litmus. The most popular and universally used indicator is litmus. It can be used either as a solution or as strips of litmus paper. There are two types of litmus paper, red and blue. When litmus paper comes in contact with acid or bases, it changes its colors. Litmus is an extract from living organisms called lichens, as I told you before. A lichen is formed by a symbiotic association between an algae and a fungi. Now let's move to the measuring the strength of acids and bases. See, this is the pH scale, and this is the litmus paper which I was telling before. See, in an acidic solution, the blue litmus paper turns to red, and in a basic solution, the red litmus paper turns to blue litmus paper. Now let's learn about the pH scale. You have just learned how acid and bases can either be strong or weak depending on the saturation of H and OH ions, respectively. But how do we measure the strength of an acid or base? The strength can be measured on a standard scale called the pH scale. Now let's learn about the using of pH scale. A pH scale tells us how acidic or basic a substance is. Different strengths on pH scale are indicated with different numbers. The range is from 0 to 14. The midpoint, i.e., 7, indicates a neutral solution which has equal acidic and alkaline behavior. A pH value of 1 to less than 7 is for an acidic solution, while the value greater than 7 to 14 is for an alkaline solution. The pH value of 1 for the solution signifies that the solution is a strong acid, while 6 signifies a weak acid. Similarly, a pH value of 8 signifies a weak alkali, uh, while 14 signifies a strong alkali. As you can see, the pH value of 7 is pure water. Universal indicator and pH scale. Now you can see these are the universal indicators. If you cannot know still, see these are the universal indicators. Indicators like litmus and phenolphthalein cannot show us how strong or weak an acid or a base is. For this purpose, we use universal indicator. Which is a mixture of different organic indicators to find out the strength of an acidic or basic solution. A few drops of the universal indicator are added to the solution. The color of the solution changes to a specific color indicating a specific pH value. By comparing this color with the standard chart, the pH value of the solution is determined, which shows exactly how strongly acidic or alkaline the solution is. Now, let's move to neutralization. Now, let's move to neutralization. We have learned that when an acid reacts with a base, it forms salt and water. Such a reaction is known as a neutralization reaction. Heat is involved during this process. Now you can see here acid plus base gives salt plus water. For example, when hydrochloric acid reacts with the sodium hydroxide, we get sodium chloride, common table salt, and water. HCl, which means hydrochloric acid, plus NaOH, which means sodium hydroxide, gives NaCl, sodium chloride, plus H2O, which means water. Now let's go to the types of salts formed. Depending on the strength of an acid and base taking part in the neutralization reaction, different salts are formed. These salts may be acidic, basic, or neutral in nature. For a strong acid plus weak base gives acidic salt plus water. For example, hydrochloric acid plus ammonium hydroxide gives ammonium chloride plus water. Weak acid plus strong base gives base, basic salt plus water. For example, acetic acid plus sodium hydroxide gives sodium acetate and water. Now in this first example, the ammonium chloride is an acidic salt. And in the second example, sodium acetate is a basic salt. It's an acidic salt and it is an basic salt. Now the third example, strong acid plus strong base gives neutral salt plus water. Example, hydrochloric acid plus sodium hydroxide gives sodium chloride plus water. Now you may know that acidic salt and basic salt is over. Next which is? Yes, next is neutral salt. That is sodium chloride is the neutral salt. Thank you. This is the end of this chapter, acid, bases and salts. Let us meet again with the next chapter. Till then, bye bye.